Okay, so today we're going to be looking at doing substitution in definite integrals. Not indefinite integrals, but maybe into definite integrals. Okay, so as it says in the aim and the topic over here, that's what you should be copying into your notebooks. So you may have actually seen an enrichment problem on like a worksheet or something where it wasn't an indefinite integral and needed to use substitution. It was the use substitution definitely needed to be there, but there was actually values for the lower and upper limits of integration. And we didn't want to keep them as x values if we were using u substitution. It's actually easier to change them into the values of u. And so that's what we want to do here. To evaluate a definite integral by substitution, we substitute and integrate with respect to u and have new, emphasizing new, upper and lower limits of integration. Okay, so you're going to see over here in the model definition of the substitution definite integrals that we're establishing what u is as a function, and we get to plug in the values of our upper and lower limits into that function. Okay, and of course we just follow through with our regular procedures for u substitution and we should be good to go. So I'm going to leave it here in case you're still copying that down, but I'm going to pull up a couple of examples we're going to do together. Okay, so for our example, our first example, I'm going to evaluate our definite integral, but we're going to use substitution for it entirely. So let me write number 1. So we see we're integrating sine of x to the 4th power times the cosine of x with respect to x. Since sine of x is raised to the 4th power, that would be our u. And our du, okay, we take derivative of both sides, is cosine of x dx. So now we can see we can substitute we could substitute that with du, and this would be u to the 4th. But what else we're going to do is plug in pi over 2 and 0 into our expression for u. So when pi over 2 is plugged in, we get a value of u to be 1. And when we do it again, for 0, use a different color here, we get a value of u to be 0. So we're going to rewrite our integral not only with u to the 4th du, but also over here we're replacing it with u equals 0 and up here with u equals 1. So that way, when we do u to the 5th over u, we could automatically start plugging in 1 and 0 and get our answer of 1/5. And there's no other like that substitution with the x values, you're done. So now if you didn't get this down because you were still on the definition or model here, okay, and you were still copying down the example, or you were just still up here instead of down here, please make sure that you just pause or stop the video and write it down. You have to do these problems yourself, not just watch them. So we're up to number 2. I'm going to raise this. So again, just stop or pause the video if you need to, okay? All right, here we go. Okay, so for number 2, we're going to evaluate the tan of x times the secant squared of x with respect to x. Okay. So pick an expression for u. They're actually, even though this is secant squared of x, they're kind of equal as far as like complicated portions. But if you take the derivative of tangent of x, it is secant squared of x. Take 0 on both sides. This is with respect to x. So hopefully you can see how all of this would become du. So that's what we would use, okay? So let's continue to go through what we're doing with definite integrals. If u is tangent of x and my upper limit of integration is pi over 4, if I plug that in, I have a value of 1 for my new upper limit of integration. My lower limit of integration, x was 0. So if I plug that in, my new lower limit of integration is, well, u equals 0. That actually didn't change. So let's rewrite this using our expressions that we got with u. So this is going to become, when I integrate, u squared over 2, and I'm plugging in 1 and 0 because those are my u values. So you can see how we're just getting an answer of 1/2. No need to do any other substitution. We're done. So let me know if you guys have any questions, and make sure you do some practice. And you know what? Good luck.